Can AI actually program a PLC? Let's find out. Using large language models to help write PLC code could become a major shift in industrial automation. Today I'm going to build a traffic light state machine in CODESYS using structured text. But the goal is not just to show AI generating code. The real question is, can AI help automation engineers move faster while still keeping engineering judgment in the loop? For this demo, I'm starting with a simple 4-state traffic light intersection controlling north-south and east-west traffic. Instead of writing the structured text manually, I'm going to define the requirements in a prompt and let the AI generate the code. One thing I learned very quickly is that prompt engineering is crucial to your success. The AI only knows what you tell it. If the requirements are vague, the logic will be vague. But once you clearly define the states, timing behavior, transition rules, and control constraints, the generated PLC logic becomes much more reliable and deterministic. And that is where real automation experience still matters. The engineer still needs to understand the process, timing sequence, machine behavior, and how the control system should respond under different conditions. For this first example, I'm defining a 4-state traffic light sequence, a single T-on timer controlling all transitions, deterministic state behavior, fixed timing requirements, and structured text output for CODESYS. The important part is not the exact wording of the prompt. The important part is translating engineering intent into structured requirements that AI can work with. Let's send the prompt in and let the AI generate the structured text. And in less than 30 seconds, the AI generates a complete traffic light state machine. Now let's see if the code actually works. I'll bring the generated code into CODESYS, build the project, and test the logic on the PLC. Let me first copy the variable block from Claude and paste it into CODESYS. So there is your variable declaration. Now we have to go back to Claude and copy our main program. We copy the main program. Now we go back to CODESYS and we paste it into the main program. Let's go compile and build the program. Wow, that's amazing. The project compiled successfully. Download the program to the PLC. Now we run the program. Let's monitor the state transitions. We can already see the state machine cycling correctly between green, yellow, and red. For a simple state machine like this, the result is actually pretty impressive. Let's stop the program and log out to map the variables to the actual hardware. On the digital output module, I have north, south, red, yellow, and green connected to output 1, 2, and 3. On the east, west, I have the red, yellow, and green connected to outputs 5, 6, and 7. North, south, red. North, south, yellow. North, south, green. East, west, red. East, west, yellow. east, west, green. I download the new changes to the PLC. Let's run it. Yes, it turns from green to yellow and red, and it turned green on the other side. So can AI help automation engineers move faster while still keeping engineering judgment in the loop? For this first experiment, I think the answer is yes. In less than 30 seconds, AI generated working structured text. The project compiled successfully and the PLC logic ran correctly. But AI didn't replace engineering. The requirements still had to be defined, the control behavior still had to be understood, and the final results still had to be tested and verified on the actual system. AI accelerated the workflow. The engineer still provided the judgment. But this is still a relatively simple example. Real automation systems involve inputs, operator interactions, interrupts, and more complex state behavior. So in the next video, I'm going to increase the complexity by adding pedestrian crossing buttons and see how AI handles asynchronous events and changing requirements. I'll also introduce CODESYS MCP and test a much more interesting workflow where AI can modify the project directly instead of relying on copy and paste. And that's where things start becoming much more realistic and much more interesting. Thank you for watching. I'll see you in the next one.